So this section 7.1 will study about integration by parts. And remember the product rule. Differentiation of a product will be, suppose we differentiate the product f and g, it will be f times g prime plus g times f primes. And now if we take integral both sides, right, it will give us the equation here, integral of f g prime dx plus integral of g f prime will be equal to the right-hand side. The right-hand side is the integral of f g prime here, right? Integral is antiderivative. So, and finally, it gives us f times g here, right? Basically, this is entire section. Just memorize this. Then now, suppose we're given an integral, which is integral of f g prime dx. Then we can apply this formula to find this. So this is a very important formula. You can use it. You have to use it many times in the future if you are still studying mathematics. And this is a very beautiful formula. So another way to memorize it. So if we call the function f is u and the function g is v, then we can write the formula as this form. So remember, if u is equal to fx, then du over dx will be f prime, right? So if we multiply both sides by dx, what do we have? Here, right? So as we can see, f prime dx, we can write it as du. Look back here, f prime dx. So it means that we can replace it and write it as du, right? G is, we can replace it by v. Same here. And the similar story, if we replace g prime dx, it will be dv, right? That is the reason why we have the second formula here. It's nothing new. So when can we use the integration by parts? So if you see some problems that is difficult, so let us just take a look at this example here. Remember that the table of integrals, different differentiation rules, we don't have any formula to solve this one. It's kind of difficult. But if we define f of x, the function f of x is x here, g prime here is sine x. So suppose we write it in two columns. Let us write it this way. From the formula here, integration by parts, what do we need to know? If we are given f and g prime here, we are given f of x, and we need to compute f prime, right? This one. That is the one thing we need to do. If we're given g prime, we need to find the antiderivative of g prime, which is g. So these are the only two things. Suppose f of x is x here, and g of x, g prime of x, here is sine x. So in order to apply this formula, we need to find f prime, right? from this, what is f prime? Yes, derivative of x, right, which is 1. Okay. So the second one, if we're given g prime is sine of x, what is the antiderivative of this one? Very good. If you don't remember these formulas, please go to the website, the Moodles. You will see that there are 2 tables. I put it in the notes, week 1. Find the tables and write the formulas yourself. And this will give you these formula. So in the future, if we want to use integration by part, this is the trick I normally use. So we take this proportional rules. Suppose, imagine, the result will be the product of this guy, f and g here. Okay. Subtract g f prime, subtract this guy. So this, the positive sign, right? Subtract f prime, g f prime. So this is how we can memorize it in my way. So it's up to you. So this is the whole idea. So from this, we want to compute this guy, right? So applying the formula, what do we have? Very good. So this guy multiply with this guy, which is x times negative cosine x, or the way you do is very fast, but let us just write it this way slowly. And then the negative sign here, right? Subtract the integral of g f prime. G here is negative cosine x, right? F prime here is this guy, which is 1. And we're computing the derivative with respect to the x variable. So integral that 1. So now the problems becomes easier. So here, x times negative cosine x give us negative x cosine x, okay? And here, 1 times negative cosine, and in front of that there is a negative sign, and finally, can we simplify it? Right, negative times negative inside here give us a positive cosine dx. So what is the antiderivative of cosine x? Very good, thank you. What is your name again? Camden, thank you. So, is it enough? Yes, plus a constant, right? A families of function, because we're computing the indefinite integral, plus c, where c is a number. A constant. Or in the exams, you can simply write c in R, okay? But we create a new variable c, you should define it, okay? That's it. So That's it. The integration by parts. There's nothing new. But suppose we need to compute the same integral, but in the intervals, right? What you need to do is to simply suppose we're computing from the interval from A to B, then it will apply to the whole result here. Integral from, let us write it as x is equal to A, x is equal to B. Integral from the same intervals from A to B, right? And here, this guy, let me just write it in new formulas because, yeah, I don't want to confuse you. Similarly, if we're computing from A to B of x sine x dx, then this guy will be x times negative cosine x from this interval from x is equal to A to x is equal to B, right? Subtract the second one, integral from A to B cosine x dx, or in the end, it becomes, what is it? Very good. Cosine x from x is equal to A to x is equal to B plus this guy from x is equal to A to x is equal to B, right? That's it. So in order to use integration by part, just remember that we need to define which one is the function f, which one is the function g primes. The second steps is to find f primes and find the antiderivative of g primes, then apply the formula, right? That's it, the whole chapter, the whole idea. So another way to find the solution, instead of using f and g, sometimes we use the notation u and v here. If u is x here, dv is sine x dx, right? Because the original question is integral x sine x dx, okay? This is dv. The same rules, okay? You multiply this guy with this guy and subtract the integral of this guy, and the sign of these will be plus and negative. Okay, therefore integral from x sine x dx will be uv, which is x times negative cosine. Let me just write it this way. uv subtract integral v du, right? And we replace that with this. It becomes x negative cosine x subtract v is this guy, negative cosine x, and du is the same as dx here, right? And it recovers the same result. Is there any question up to now?
For the definite one, would you want us to leave it the same way that we finished it, or would you want us to pivot to like actually work out where x equals b and x equals a?
Yes, we need to actually work out. Okay. For example, Yeah. So this is the formula if we are computing the definite integral. So now let us take a look at the example here. Okay. Integral. The second one. Second example. Integral of natural log x dx. Do you have any suggestions for defining u and v? Let us play with u and v, dv, right? It seems to be easier. Your point of view. So let me rewrite. Keep this, okay. Or okay. U is natural log of x.
Well, no, I'm asking.
Oh, yeah, this is natural log of x.
Um,
Okay. The thing is that what is so if we defined natural log of here, if you define u to be 1 and natural log of x is dv, you need to find the antiderivative of natural log, right? And it becomes difficult, right? So how about we do the other way around? If we do this to be natural log of x, and this one is 1, right? So we need to compute u prime, okay? So what is u prime? 1 over x, thank you. So we take derivative of both sides here. And this is natural log of x derivative, give us 1 over x, very good. So antiderivative of 1, what is it? Yes, x. Okay, the same rules. Multiply this with a positive sign and subtract this integral of this one. Therefore, we have that integral of natural log of x here, dx. It will be what is it? Yes, x times natural log of x. Very good. And louder, please. It's fine. Yes. Yes.
Oh,
Okay. V du, right? V du and du. Look at here. if we write u prime would be du over dx, which is 1 over x dx, then du would be 1 over x dx, right? And this is our dv here. So this becomes a lot easier. X natural log of x here, subtract. Can we simplify this one? Yeah, 1 dx, right? So x dx, we just rewrite it. X natural log of x here, and integral of 1 give us is it enough? Very good. Remember the number c. And c is a new thing. We need to tell reader that where we take it. It is a real number. It is in R, right? So, does it? Suppose we are computing this guy from the interval from 1 to e, right? Should we do? So we do the same things. We define u to be natural log of x, and dv is 1, right? The same procedure. We need to find u prime, which is 1 over x here. Or we write it, du is 1 over x dx here, right? Same things. And v would be integral of this, which is x. So the rule is like this guy. Therefore, integral from 1 to e natural log x dx will be uv, which is x natural log x here, from this interval, right? Remember, just write it here clearly. From x is equal to 1 to x is equal to e. E is simply a constant. It is 2.7 something. Okay, treat it as a constant. Then the second one will be subtract integral from this interval from 1 to e and v du, which is x. Very good. Okay, right. So let us rewrite the first terms. And the second one, the same story. It will be integral of 1, which will give us x, right? Do we need to write it in details, or we skip this step and write it immediately? Okay. Are we good? Then, so we know the upper bound and lower bound fundamental theorems tell us that, okay, we substitute the value of the upper limit. So we replace x by e, which will be e times natural log of e, right? That is the first evaluation of the upper bound, and subtract the evaluation of the lower bound, which is x is equal to 1. Okay, this is the first term. Are we good?
Since the bounds on both of the, I guess, numbers are the same.
It is a very, very good point, but we'll discuss that a little later when we finish it. Very good point. Save a lot of time writing it. So this is the first one. And the second one will be subtract. We need to evaluate the second terms here, right? Let us write in different colors. So at the upper limit will be equal to E. Therefore, it will be E minus the evaluation of the lower limit, which is 1. So remember, the sign here is very tricky. So don't forget the parentheses here, the bracket. Otherwise, you will mess it up. Okay. Then, okay, let us simplify it. Here, E is a constant. In front of that is a positive sign. We can ignore the bracket. So natural log of E give us, very good, 1. And what is natural log of 1? Yes, 0, it means 1 times 0. Very good. So subtract. In front of the bracket is a negative sign. If we want to remove the bracket here, we need to change the signs of things inside. It was positive E, then we remove the parenthesis bracket, it becomes negative E. Here, it was negative 1, it should becomes very good. So that's it. So here, E times 1, subtract E, cancel, right? 1 times 0 becomes 0, and in the end, it just a number 1. Okay. So from the fundamental theorem, we know that integral of a function in a certain interval gives us the area, or it will be a number, right? An area of will be a number. However, indefinite integral will give us a families of functions, right? These are the two key things about the definite and indefinite integral. So, very good. Do you have any question up to this point? Yeah. So our job now is to practice. Does it? The integral by part. Very well. So let us play with another example. Okay. Suppose we need to compute, let us call it I, the integral of t squared times e to the t dt here. Okay, using integration by parts. So we know that we need to define something to be u, and the other one will be dv, and we need to compute du over dx, or simply write u prime. And we need to find the antiderivative of v here. So look at this. Which is which? If you need to define it. We need to find the antiderivative of one term and find the derivative of the other one. So e to the t is u. Let us, if we do it this way, so then t squared will be dv, right? If we do so, it is easy to find u prime, right? Let's try. Okay. And what is the antiderivative of dv? T cubed over 3. Then applying the formula, we know that we need to multiply this guy with this guy and then subtract the integral of this and this. Okay, what do you see? What do you think about it? It's becoming even harder, right? We need to take an integral of something t cubed here, multiply with this guy. Let us just write it out. E to the t uv, which is e to the t and t cubed over 3 subtract, what is it? Next. Dx, right? It's even more complicated. So this way does not give us a better solution. So what should we do? Very good. Is it clear? So let's try the other way around. So, okay, if we defined u to be t squared and dv will be e to the t, okay, we need to find derivative of u, what is it? Okay, 2t. What is antiderivative of dv? Yes, e to the x, e to the t, derivative will be e to the t. That's it. So integration by parts, u v, which will be yes, t squared times et and
minus the integral of 2t to d to the dt.
perfect. Okay, beautiful. We have these. Then, okay, we have, it will be t squared e to the t here. This guy, okay, let us, the constant, we can take it out of the integral signs, right? It is t e to the t dt. This is another one. What should we do? Let us call it I1, okay? Then we do integration by parts again. Good point. Now, so let us compute integral of t e to the t dt. Okay, then we do need to do the similar things. Let us call it u1 and dv1. So what should we do? What should we define here? T, okay, and here e to the t. Very good. It means that we need to compute derivative of u1, which will be, and we find v1 e to the t. Very good. Okay. Now the same things in this one, subtract the integral of here. Okay, therefore I1 will be, what is it? In? Perfect, thank you. So, do you have any question up to this point? Everything's clear, right? Great. Then, so this guy, we just rewrite it. How about this guy? What is antiderivative of e to the t dt? Yes. Is that enough? Very good. We need to add a number c, where c is a real number. Okay? So we know I1, but our job is to compute I, right? Okay? We substitute here. I will be, let me copy it here. Okay. And from the above computation, we have, it will be 2 times t e to the t here, right? And subtract e to the t plus a number c here, okay? Then what do we have here? Be careful, be careful here. Yeah, it's a common mistake. Everyone could make it, even, yeah. And 2, right? In front of that is a negative sign, so everything inside, we would change the sign of it. Okay, where c is a constant. Okay, negative c or plus c doesn't matter here. Okay, oh, you're right. Actually, it should be minus 2c. But in your final computation, minus 2c is simply a constant, right? You can write it as I will be t squared e to the t minus 2t e to the t plus 2e to the t plus m, where m is a number. It doesn't matter, just a constant. Okay. But thank you. That's a good point. So that is one way. Can we do it faster? How can we do it? Let us summarize it a little bit. Because we know that the first column would be u, and we define it to be t squared here at the very beginning. And the dv column, let me just write 2 columns like this. Okay, u, the first guy would be t squared. And it is e to the t, right? Let's try to take the derivative of the left-hand side. Derivative, let us what is derivative of 2t here? Of t squared, it is 2t, right? Okay. And antiderivative of this guy. Very good. The next step, keep taking the derivative on the left-hand side. It gives us, yes, 2. And keep taking the entire derivative of the right-hand side. Yes, e to the t. Okay, you can remember this trick. We multiply it this way. This guy multiplied with this guy with a positive sign. This guy multiply with this guy. This is positive. Then let us change the sign here. And finally, at the end, multiply this guy. And because in front of that is negative sign, let us place it a positive sign here. Okay. So we can do it quick like this. Instead of doing integration by parts 2 times, applying this trick, you can write the final result immediately here. This multiply this, it will be t squared times e to the t, right? The second one will be this guy multiplied with this guy, which will be 2t e to the t. The last one, we take integral, okay? In front of that is a positive sign. So we take integral of e to the t here and multiply with 2 dx, okay? This is a trick to do integration by parts multiple times at the same time. And if we do it this way, we will have t squared e to the t minus 2t e to the t here into antiderivative of this give us 2n. Yes, plus a number. Double check the result. What do you think? They're the same. You can do it as many times as you can. But remember, just change the sign. Every time it's changed from plus to minus.
Would you recommend using the shortcut for like only step?
So from your experience, when you do many problems, you see when you do it. Yes. Yeah. For this situation, it is recommended to do it because it saves a lot of time. I'm sorry, now class dismissed. You can leave if you want, but if you have any question, you can stay here. I'll answer you. Say it again. Yeah. You're welcome. So you have a good one. Thank you.
So this in this part, this one.
Yeah.
You're not supposed to like yes to the everything in there.
Distribute everything.
Okay, and that's gonna be the answer after that.
Thank you. You're welcome. Thank you. You're welcome. Have a good one. You're welcome. See you, Eddie. Thank you. Oh yeah, just practice problems, extra problems for
Okay.
you to practice.
So we don't give this to you?
You don't have to.
Okay.
You're welcome. See you. Yes.
So, question.
Yeah.
So last year, or last fall, I actually had to take this one. So
Yeah.
So I took top one a year ago, and so some of these things I'm kind of I've forgotten. So what would be like? What do you think would be the best approach to going into this class? Like, should I just start?
Yeah.
Just read a whole lot, just try to memorize.
Just do practice problems and study the lecture notes I give you every day because I summarize it already. So however you go, don't worry. Just do practice problems. You're welcome. Yes.
When you were taking the derivatives and the antiderivatives of like the like u and dv, how did you determine what signs?
The signs of each terms.
Yes.
Yes, it just start with a positive one and then the next one would be negative, and then you change sign.
Okay.
Yeah. Positive, negative, and positive, and just keep going on that way.
Okay.
And the last one, we'll take the integral. And that's it.
Thank you.
You're welcome. You said something about login in the Moodle and yes.